Okay, I think it's on. Let me share the screen for today's agenda. Here's my screen.
Yes, I can see it.
Thanks, Payment. Okay, I think we can get started. There could be more people join, but let's start it. Today's agenda, I prepared two topics. Um, One is to continues to discuss uh, the comments that Pritesh shared in the Slack channel, and also um, Shui provided the feedback. Let's try to summarize this in this meeting. Another topic is about our upcoming release. We originally planned in May this month. So basically, we are already past 1 month for May. So we needed to check the current status. And I also have a proposal. Um, yeah, so let's discuss this when we are talking about this topic. So the first topic, maybe Pradesh, you can drive the discussion, or
Sure, I was trying to find my unmute button. Yeah, I was supposed to reply, but I forgot to reply on GBS comment. I have a reply draft. Let me share it here, and I will reword that and add it to the Slack channel also. I just need to add more context there for commenting on Slack. So the idea is, I think the basic debate right now is about when should we do the signature verification? Should we do it always, or should sorry, when we should do timestamp verification? Should we do it always, or we should do timestamp verification only if signing certificate has expired? And from what I read, uh, ultimately the decision came down to a point where we are saying there's a trade-off between the availability and the brittleness of timestamp or expiry, basically signing certificate expiry. But that's where that's where the trade-off is. Does that make sense?
um, so Pradesh, you are actually talking about the first one, right? It's about whether we should always verify timestamping, or we just
Yes.
verify when the sign certificate expires.
Yes. So when we always verify timestamp certificate, the good side of that is when your certificate expires or before and after certificate expires, the behavior is exact same given the inputs are same. We no longer relies on system clock to change the behavior. If the system, if the inputs are same, the output would be same. The downside of that is, yes, we will have to do extra computation there to verify the timestamp signature. And there might be additional revocation calls, which would be unnecessary in case signing certificate has not expired. But that's the downside of that. Now the upside of only verifying timestamp signature if certificate has expired is, okay, when certificates are not expired, you don't have to verify a timestamp signature. You don't have to make a revocation of call for timestamp signature. That's the upside. You're doing the less work. But the downside is, if the timestamp signature was corrupt, your existing workflow will stop because your signature will start failing verification. So that's the high level trade-off here. And she will also bought a couple of points for security and availability, which I tried to address in the comment which I pinged on Zoom. That if, for example, there was one point about if what if attacker strips off the timestamp verification and this will fail the signature. So what if attacker strips off the TSA signature timestamp signature, which will ultimately lead to signature verification failure? I mean, if a repository is compromised, they can just alter or corrupt the signature, causing the signature verification to fail. I think there was one more point around bypass of signature verification for in the scenario where, let's say, user has configured TSA and the trust policy, and attacker goes and removes the timestamp signature from the actual signature. This might lead to earlier with the signature which was failing verification will now succeed verification. Yes, there is a downside which we can address by including a hint like in while doing signing, saying okay, this the signer intention was to timestamp it, so we can have a signed hint that okay, always look for timestamp signature. That's one way to address that. But again, they also call out that this actually reduces the security of the this actually lowers the security bar. I would say no, because the alternative which we are suggesting where we won't even evaluate the timestamp signature, this holds up the same bar. Sorry if I was rambling for last 2 minutes, but does that make sense? Or or do you want to discuss point by point?
I think it would be great that we can
Oh, yeah.
discuss.
Uh, can you open the Slack? Can you copy paste the CVS response on the Slack and we can go over point by point? Or can you
Uh,
share that? Yeah, that would be easier for me.
Okay, let me do that and copy it. And this is the first part, then the second part.
Can you show it on the HackMD? Can you just put a new screen on HackMD and put it there? It would be easier for everyone to read. I'm not sure. I can share the screen.
Okay.
Let me open that and let me share the screen. I will just open a time. Oh, yeah. Let me just copy paste the content and I will share this subline. Zoom, share screen. Where is share screen? Okay. Can you see my screen?
Yes.
Okay, cool. So let's go over one by one. It's not good, but that's what I have right now. Okay. So initially my proposal, just to summarize my proposal and what Shiva wrote then, and then we can talk about. Initially what I said was, okay, instead of running timestamp signature only on expiry of the certificate, let's always verify it. Yes, it doesn't provide any security guarantee, but it just provides a deterministic amount of work our verification library would be doing in all the cases. Also, it eliminates a scenario where verifiers are surprised because yesterday my signature verification was succeeding, but today the certificate expired and it's failing because the timestamp signature was either corrupted or wasn't signed by my trusted TSA. So it avoids that scenario. That's what I was proposing. Then Shiva brought a couple of good points about what are what might be the downside of the proposal. The first point was around the security. The point says that an attacker or a adversary can go and modify and strip out the timestamp signature because they are stored as unsigned artifact, which may lead to the lower availability of verification operation. I would say yes, that is true. But if the registry is compromised, the attacker can anyway lead to failure of signature verification. Yes, Shiva, you have your hand raised.
Yeah, the attacker may not corrupt the registry, but when the signature is copied from one registry to another registry, the attacker can hack in the middle. So basically, the attacker does not copy the original signature, but modify it and upload to the new registry. So basically, it does not corrupt any registries. It just modify in one copy.
Yes, in that case also, if that operation is compromised, I can just corrupt the signature, which will lead to the verification of signature, which will lead to the failure of signature verification.
But that can be easily detected because you modified original signing signature. But if you modify the time stamping, then it is without detection.
Output is same, verification failing, right? It doesn't matter the detection. I can lead to the degraded availability because signature verification is failing in both the cases, right? The end outcome is same.
I'm not fully convinced because even if they are failing, the verification failure reasons are different, right?
Yes, either it can be timeout or signature verification failed, but the ultimate, the failure reason can be different, but there is a failure. So there are other ways to
Uh,
exploit.
yeah, and also, what if the attacker just remove all the stamp stamping signatures?
Yes, so we already set a premise that timestamp signature is not for additional security. It
But
doesn't.
yeah, as you mentioned, it's not for additional security, then because it's a counter signature, we should not rely on a counter signature for a critical path of verification.
We are relying because we want to avoid the brittleness which is caused by signing certificate expiry. Because there are scenarios, for example, I took a signature which was time stamped. Let's say either the timestamp signature was bad or it was by an untrusted third party. What as a verifier, I thought, okay, I have a timestamp signature, so it's even after signing certificate expiry, this should continue to work like it's working yesterday. But the time when signing certificate expires, everything stopped working because verification started failing. And there is no good way to test that also upfront, unless I move the computer system clock or notation provides a tooling to do that.
Yeah, then why not? I mean, this kind of check can be done at the signer side when the signing is done immediately. While we need to let the the verifier to do so,
Because that's
right?
a signer and verifier
It can be
can
done once. Why it need to be done 100 times after signing?
signer and
I don't
verify
know why.
signer and verifier can be different personas. They might not belong to same organization. The person who is configuring trust policy and trust store is different from the signer.
And also for different I mean for different verifiers, maybe one I mean for example, if someone doesn't care about any timestamp signature in this signature, then if you falsely verify the timestamp, it will always fail
They
because yeah.
They can mark this verification extended validation, whatever we call it. Sorry, trusted identity validation as skip. In that case, we will never look at timestamp expiry. We don't even care about signing certificate
Well,
expire.
no, no, no. No. Okay. So wait a second. So basically, yeah, I mean, you mean that, um, oh, okay. This is a bit strange, but okay, just go ahead.
Yeah, I think the trade-off here basically is to avoid the brittleness, do we want to do extra work or not? That's like, so there is a brittleness which I think everyone will agree upon is saying that, okay, it would be like yesterday signature action was passing, today it failed given the same input and everything same. Even it was time stamped, but let's say I don't trust the timestamp or timestamp signature was corrupt, which is really bad situation to be in when your production workloads are impacted. Because it was passing yesterday and today it's not. But yes, again, that comes as a cost of doing additional work every time. And yes, there is some availability risk if we're checking a revocation response, but yes, that's a trade-off here. Any questions on that? Any feedback?
Pritesh, would you mind explain again the additional scenario that always checking timestamping will prevent?
Yeah, so let's say you are using a short-lived signing certificate of 1 month or a year roughly. Okay, let's assume for 1 month right now for the scenario. As a signer, you signed the certificate, you generated a signature using the certificate, which is validity of 1 month. You timestamped it and you send it to the verifier. Now, let's say verifier made a mistake in doing trust policy configuration. Verifier made a mistake of putting a wrong TSA as a verifier, as a trusted identity, sorry, trusted trust store. They have configured trust store is wrong TSA. So what will happen is, till the time certificate is not expired, signature verification will be successful because we won't verify a timestamp signature. But once signing certificate expires, signature verification start failing because the TSA trust store for TSA is configured wrong, but the user might expect it to be right. So it's like yesterday everything was working, but now today everything is broken. I don't know why the inputs are same. Why might I have timestamp my signature?
Okay, so
It's like misconfiguration in trust store or during copying somehow timestamp signatures. Like, yeah, somehow timestamp signature was corrupted or something like that. Or timestamp certificate was revoked, which is a case which might happen and which might lead to a disruption. That's a separate scenario. But like in normal scenario, timestamp, like say doing signing or after signing timestamp signature got corrupted. So ideally, I would want to know as soon as I deploy the new artifact, not after a month of deployment.
um, yeah, but it seems that yeah, for
Mhm.
this case, it looks like a configuration issue, right? But we try to avoid it by performing additional requests, right? And every time.
Yes. It's like brittleness against extra work. And anyway, once certificate expires, you have to do that extra work.
But for the most of the time, the the signing signature, the signing certificate will not expire, right? For the most scenarios.
It depends upon the organization policy if they are using like short-term certificates and timestamping relying on that.
Yes. As you mentioned, it depends on the organization policy. Uh, so why not just we have a config, additional field in the trust policy saying, okay, you can turn on the always check the timestamp signature to true, then we'll always check. But if it's not set there, then we have the default behavior that it will not always check. So we can let the verifier to choose by overriding their trade-offs.
Makes sense, but what should be default behavior? I
Because
agree.
for me, I don't think it has more benefit than the disadvantages.
I mean, there is a benefit of not having a surprise on one day that okay, it's not working with some extra work. I mean, this is a common scenario which might happen, and we might be fail here. So this is a common scenario where day 0, someone signs it for 30 days. With TSA, day 15, signings verification was successful. Although my trust policy says trust timestamp server B, on day 31st start failing.
Yeah, so basically, I think this one is optimized for short-lived signing certificates. But as you know, most of the time, those signing certificates are lives longer, like 1 year.
Even with
So
one,
uh,
there are systems where you don't make changes for a year. And there would be outage on the, say, 66 day of signing. It's like it's a more of a hidden failure scenario.
yeah, but I don't think we should have this kind of check because this check can be done at the signing stage, uh, by trading off the performance and availability as well as the security. I don't think it's not a good idea by default, just for optimizing a part of the scenarios. It's not for all the scenarios, especially for the scenarios where the certificate has longer expiry time.
Okay, let's talk about availability and security. Security availability is still same because you might want to run your workload after 366 day also, unless you are saying we don't want our workload to fail after 366 day if there's no deployment. So even if a year certificate, are we saying that we are okay for a workload to fail after 365 days of signing?
Yes,
I'm assuming
because I think lots of the um, scenarios will only care about the signing certificate. They don't even have a timestamp.
okay. I mean, this is a this is a this is an invisible failure which will surface suddenly for customers because they are time stamping and it's not there. If they're not time stamping, then yes. And the security is still same. Security we are not lowering down at all. Security is still same for scenarios. Time stamping is never for security purpose. So it's the trade-off is about
But
availability and brittleness.
yes, it's a bit strange because, for example, uh, uh, okay, you have a signing certificate, right? Assigning a signature, and it can pass the verification. But once you add a timestamp, I mean, add an invalid timestamp signature to it, it start failing. But
Oh,
but later someone can just remove the timestamp signature, and now it starts passing again, right? And it's totally without detection, and it's also without signing because it is in the unprotected header. So
yes, I agree. That's
that's
a good
really
point.
strange.
Yes, that's a good point, and we can circumvent that by adding a hint in the signature that okay, verification expect a timestamp certificate with this. If signer wants that, so that can be fixed. That's why security is not really a problem. For example, when you want to add a timestamp as a part of
Yeah,
added that okay, it always needs a timestamp signature, so we can field the
yeah,
verification.
yes. There's another option, that is you are actually suggesting that moving the timestamp signatures into the protected attribute.
No, I'm
Is
not.
that your
No, just add a signed parameter saying that look for timestamp signature.
Then that's very strange because the attacker can update the timestamp signature,
Yes, if it's
right?
trusted the trust store, then we are good because user trusts that trust store. So it's same as that.
Yes. For example, what if the user have two trust? For example, they trust two TSA trust stores. Uh, Basically, the attacker can update the signature without notice, changing the TSAs.
Yes, and that's a valid scenario because you trust both TSAs. If you don't trust any one of them, don't add it to your trust
My
store.
point, yeah, my point is it is without notice, and the signer will never know because this unprotected. It's not signed.
It's same as the other scenario, right? In other scenario, when you only verify timestamp when certificate is expired, it's same scenario as here, right? Both
I, I, I think I think the verifier should verify the signature as it is when uh, when the signer, the original signer, signs the signature. It should not be modified in any way.
okay. Let me put it other way around. An alternate which we were discussing, let's say your signing certificate is expired and it was time-stamped, okay? Now someone goes and replaces the timestamp with other timestamp and you trust both the timestamp server. Does this
Yes.
scenario does the security still applies in that in that scenario?
It can be, for example, TSA uh, serves longer, but TSAB might be shut down in a very short time. So basically, their lifetime are different. It's not totally equivalent.
Yes, but scenario applies to both the scenarios. The security issue which it called out applies to both the scenarios,
But
right?
but if the timestamp is signed by a signer, so basically the trust is fixed.
In
So
both the cases.
there's no chance for the attacker to change the trust.
Yes, in both the cases. Whether you verify the timestamp every time or whether certificates or in the scenario when only signing certificate is expired. It applies to both the use case. Yes. You can solve this with multiple, either adding a hint or include timestamp signature as a signed attribute. I agree there, but this applies to both the use cases. It's not to one of them. So we are discussing two alternatives and applies to both the alternatives. Right? So again, the discussion points comes to the availability versus brittleness. Whether you want to do an extra work from start or only whether you want to do that work from start, the additional work to verify timestamp signature, or you want to do that additional work after you are signing certificate expired. So it ultimately comes down to that. That's what my proposal is. Like doing the additional work removes the brittleness in the system without any downs, with additional downside, with additional work which you have to do every time. And this has no degraded security or downside of any security implications in with like both alternatives have similar security guarantees. Any feedback on this? That's what I was planning to do is create an issue and we can ask for everyone's opinion, and based on the issue and votes we can decide how we want to do how we want to go ahead. And I do agree with Ria. She should finalize it by Wednesday or Thursday end of day. It should not take more time.
Shui or Patrick, any comments on this?
So if we always verify the timestamp and see everything works fine, but when the signing certificate at the day of the signing certificate expires, at the same time the TSA's cert is revoked, do we still have the same issue?
That always adds, and we will always have a brittleness of revocation.
Sorry, pardon?
We always have brittleness of revocation. If we can come up with an alternative which we can address with, I am happy to incorporate.
Yes, I
Like,
mean, in the case that I mentioned, I don't think the always check timestamping would solve the issue.
just it lowers down the brittleness. I do agree there.
Yeah.
Revocation always has that issue that there is a network call made out of the system. So,
And
sorry, please go ahead.
yeah, and in addition that some services that have timeout restrict on the verification would have a performance issue if we always check the timestamping, because the
I would,
revocation has more overhead during revocation check.
yes, so I would put it like this. It's usually good to know the issues upfront on when you're actually trying to set up the system instead of one fine day when things break. So for example, right now you're not doing a revocation call, but when the signing certificate expires, you will start making a revocation call. So if you have to make any network configuration changes on your system to allow that revocation call, you can do it upfront and validate that. So it adds to that point, right? It removes that brittleness of doing an additional work after some point in time. So the thing which is worrisome here is, I mean, I do see there is an issue here, but at least if I know a system is working right now and no out of band change has been made, it will continue to work. Okay, if we don't have any more feedback, what I will do is,
Yes, I sort of agree with Shiwei's comment here. I think the timestamping counter signature should not be a critical failure for our verification path. It's an unsigned attribute.
it will become a critical path, right? Yes, right now for example, in this day 15, it's not on critical path. On day 66, it's on critical path. Either you don't timestamp at all or we include as a signed attribute. Yes, I do agree that. So we have to make sure we have to devise in a system such a way that if it's on critical path, it's always on critical path.
But if we manually remove the timestamp signature from the envelope, then it's not a crypto path anymore. So basically, there's no change at the signer side, but it is by modifying the signature, it changes the verification process of the verifier. That's super strange to
Yes, I
me.
agree. Yes, I agree there. And we can fix that by adding a hint saying that, okay, always verify a timestamp signature or have a timestamp signature as a signed attribute. I do see that as a downside, but we can fix that. For example, I can have a signed attribute saying a special signed attribute name. Okay, always verify timestamp signature equals to true. In that case, you
Yeah. So
cannot pass that.
yeah. So I'm not sure. So whether your scenario has a real application, but we can have a config in the trust policy saying that we can always check the timestamp, but I don't think it should be the default value.
Mm. Okay, since we have conflicts here, what I will do is I will create an issue and we can poll there and I will add my thoughts and we can discuss there and add a poll there. Okay, maintenance can poll and this we can decide there. And give 3 days for everyone to respond.
I think because we already have some majority of maintainers here, right? So um I think if you create an issue, then we will still end up with we still need an discussion about this. So why not we just try to conclude in this meeting?
Let me ask the other way around. Is it blocking any implementation if we are saying we'll have a config, then we can debate about the default and we can change the default anytime later, right? If it's not blocking an implementation right now.
I think not only in the implementation, but the specification, because the specification needed to describe the behavior then, right?
Sure.
Then it is the implementation. So
I mean, since this is a major decision here, I would like to give every maintainer some time to at least comment who are not even who are not even there, who are not here. Because we are changing an existing specification which says always verify to something else. So let's give three. I'm not saying let's time box it to 3 days. If they don't reply within 3 days, then we can go ahead with this. Whatever we decide in like, yeah, whatever how like whoever is voted in 3 days, we can go ahead with that.
go ahead with what? I think
Whatever
you
is the
mean
majority on the
Shui's proposal?
whatever is the majority on that poll. But I'm saying let's create an issue. Every maintainer can poll on it. And we'll create a poll on it, and everyone can comment. At the end of 3 days, let's say if you want to do Thursday end of day, how many votes we have, we can, depending upon that, we can take a call.
Shui, Patrick, any comments for this? Pradesh will create an issue. I think maybe Pradesh, you also need to clearly mention the maintainers that need to vote for this.
Yes.
Then in 3 days, I think basically today is Monday for your time, so it's a Wednesday Pacific time and Thursday Beijing time. So we
No,
will
Thursday Pacific time. Today is Monday end of day.
okay. So Pacific time Thursday, right?
Yes.
Feynman, you have your hands raised.
Yeah, I feel the scenario is still a bit vague for me. So, Pritesh, when you write the issue, would you mind clarify a bit more on the scenario, especially why you insist on enabling the always check time-stamping signature? Is that
Sure.
only the short-lived signature time-stamping signature verification, the major scenario, or is there any other common scenario that we should consider by default? If we can align on the scenarios, I think it might be good to align with the default behavior. In total, I think we are good with having to make the make the time-stamping check configurable, like Shui mentioned, having a configuration in the trust policy to make the check frequency or the check option configurable. I think we just need to determine the default behavior based on the most common scenario, right?
Yep, we'll do that. I will add that. I will add a scenario in the issue which I open. One quick question. I should also open an issue in the specification repo, right? Just to confirm.
I think so, because we first need to align on the specification, right? Then implementation.
I will open an issue in the specification repo to the end of the day.
Yeah, I think it's not about implementation. It's more about, do we have a real use case that requires pre-test proposal. So yeah.
Yeah, let's create that issue in the specification repo, list the scenarios we want to address, and also explicitly tag the maintainers who need to vote for this. Then we give a deadline, end of Thursday, as Pradesh commented. Yeah, Feynman, please.
Yeah, I have another question, maybe for Shui. As Shui debate that always check the time-stamping signature may have performance issue, right? I'm wondering how could we measure the performance effect if users enable the config always verify time-stamping set to true. For example, we met a potential user, Mercedes-Benz. Yesterday, they have more than 900 of Kubernetes clusters. That means they will have a large scale Kubernetes clusters running and verify a bunch of signatures at once, right? So for example, if users want to verify 100 TSA signatures against 100 signed signatures, signed images at once in a large scale scenario, will there be a performance bottleneck? And how can we measure that performance bottleneck? I'm not sure if I clarified my question.
Yes, it will be a bottleneck because we always check the revocation status by sending out an outgoing a request. So 100 verification means 100 outgoing requests. If one instance send out 100 requests, and if there are 900 instances, then there will be 90,000 requests at once. That's a lot, unless we have a caching system. But as you know, we are required to implement a caching system for this kind of large scale systems.
Okay, so if there's no caching system, caching mechanism in the verifier, that means there will be a lot of, for example, maybe more than 90% of verification requests are pending in the queue, in the verification queue. Is that the bottleneck that you
Yeah, that's
mean?
right. That's right. So I'm trying to avoid any outgoing request in verifying those things.
Okay, I think that's a good justification that performance issue might be one of the blockers if we want to make the default behavior to always check the timestamping signature.
Let me put it other way around. Would you like to know that bottleneck upfront in the system or of sometime in future, or get surprised by that in sometime in future?
What do you mean by sometimes in the future?
Okay, your certificates are eventually going to expire. If we have some artifact deployed with the expired certificate, at some time in future, we will send that 100 request timestamp verification request, revocation request. So that call will happen in some time in future. It's bound to happen, not today, when your certificate expires. So would you like to know that bottleneck upfront before you deploy a solution, or get surprised on one fine day, okay, now everything is failing?
I may not be totally understood the scenario that Pritesh mentioned.
Let me put it like that. Yes, there would be a bottleneck in the system because we would be sending 100 check revocation status calls, right? Verify
Yeah.
okay. Well, let's call it OCSP calls to be lack of better term, okay? So we would be making 100 of OCSP calls when signing certificate expires, right? And that's a bottleneck in the system. At some point in time, your signing certificates will expire, and that is the reason you added timestamp signature, right? So you will hit that bottleneck eventually on the expiry of the certificates.
Pritesh, that would only happen if you sign this artifact once.
And if it signed off,
in reality, certs rotated, and one artifact can be signed and re-signed many times in its lifetime. So
I agree, Patrick, but then you don't need timestamp signature if you're doing that, if you can make sure that, right? If you are making sure that your signing certificate will never expire during verification, you don't need timestamp signature. If you're
So
adding
So we are actually comparing the time the time duration between the signing certificate not expired. This is the time duration. And another time duration is the signing certificate expired.
Yes.
And the artifact relied on the timestamp to get verified. So we are actually comparing the length of these two time durations. And
Yes.
I would say that the second one, the time duration that relied on the timestamping should be way less than the previous one, than the time duration that we don't need a timestamp counter signature to get verified successfully.
I agree.
So
Let's
if
say
yeah,
then it's 10%. Will you be like to get surprised because of the bottleneck in the system in 10% of the use cases? Like I was trying to respond to the Feynman's comment that there is a bottleneck, but that bottleneck will happen in future at some time for sure. Not today, might be 2 years from now.
Yeah, it depends on how the enterprise, how the users define their expiration duration and their valid period of their certificate. I'm not sure whether 2 years or 2 months, but it's something that will be happen in the future.
I think we are making wrong assumptions here. So, first thing, let's have a consensus on the signer side. So, the signer signs the signature for all kinds of verifiers. Is that right? It will not sign one certificate. No, sorry, not certificate. The signer will not sign one signature for each kind of verifiers. Is that right?
Yeah, I think so.
Yeah. So the next thing is that, okay, that means once a signer signs a signature, then it can be verified by an individual developer. That's it does not have a performance issue, or it can be verified by a cluster. The cluster has thousands of instances and generating a lot of requests. So, for example, that means for the cluster, they probably don't need the timestamp one because it may have trouble. So, before the timestamp, before the signing certificate expires, okay, it won't verify timestamp signatures, so the performance is good. It's not over the capacity of the entire cluster. But later, once the signing certificate expires, it's starting checking the timestamp signatures. In that case, the cluster cannot hold this kind of traffic and it will start failing, but it's not totally failed. It starts degrading, right? And in that case, but this scenario should not happen because before the timestamp expires, the signatures should be rotated as mentioned by Patrick. That's for scenario for the clusters. But for the individuals, they don't have this problem. They can still continue using the signature after the signing certificate expires because it can verify the timestamping signature. So uh, for the individual developers, the timestamping feature is very useful, but it's not for the clusters. So as you can see, first of all, we should have a field to configure it. Another thing is which kind of scenario we want to optimize. To me, a notation is or notary project's target user is for the major target user is for the enterprise users. In that case, I think we should optimize for those heavily used clusters.
I think we're almost near time. You had a sorry to interrupt you here. You had a second item there in the agenda, and we only have 2 minutes. And I will, for this, can continue discussion on the issue which I will create, and we're going to poll that.
Yeah. Okay. I think we can park this discussion for now. And Pritesh, please, in your issue, you include the issue, include the scenario, and also what we discussed for the large clusters. Okay. For the second topic about the release, because we plan 1.2 in May. So basically around before end of May. But currently we still have, for example, for timestamping the specification, we are not aligned yet, and this will impact the implementation. Although Patrick has some PRs out, but still need time to update those PR based on the our current discussions. And this is for timestamping, and also we have a PR in TSP Client Go library. Those library PRs also need a review. So for timestamping, we have our specification and also implementation PRs. For sign block, Pritesh, you have your PR created, but there are some comments also not resolved, and it also being opened for quite some time. So with that, I think we needed to speed up the PR review. It took too long time, and my proposal is that we before end of May, let's have a patch release, because comparing to previous release is almost 3 months. So there are some dependencies which could including some vulnerabilities fixing from our dependencies. So we need to cut a patch release before end of May. And for 1.2, so my proposal is we have a beta release first. So that means if we have something not fully aligned, but we can have some basic alignments, then we can release a beta release. Then during after beta release, we can still polishing or revolt some changes if needed. So this will help us to speed up and also give a very good indication to our users who want to use our notation, and also based on our original planning, they are also expecting something they can start to use or try. So basically, yeah. So Pritesh, I saw you agree with this. So let's speed up on the PR review, and we plan a patch release. I will create an issue. And also for 1.2, let's start with the beta release first, targeting also before end of May. And with that, we can also have a chance later to create new TRs or update some scenarios, because beta release we have the chance that to break something. Okay. So are we aligned with this? Yeah, thanks, Feynman. If we can have some error messages, then we can include it in the patch release. But I think before end of May, the patch release will be a hard cut. We will not wait for every messages improvement to be done. at that point we release what we have. Otherwise, there's no point for the patching release. We have a time urgency for this patch release. Okay. I think we basically aligned on the release proposal, and I also saw Pritesh will try to address them by end of this week. I think that means those PRs, right? Just to
Yeah,
be,
just for the
yeah.
PR, depending on my assigned block.
Okay. Yeah, sign block PRs and also PRs in the TSP client Go libraries. And for the timestamping, let's you will create an issue. Let's get alignment on that on Thursday. Then we start the implementation or update the implementation PR. Okay, cool. I will summarize it and put it in our meeting notes. Thanks, everyone. Bye.
Thank you. Thank you, everyone.
Thank you.
you.
Bye.